Welcome, I'm Justin. I want to pass you through drawing statistical diagrams, and these are the softwares that you'd need. You need GeoGebra software. You also need Microsoft Paint, and you also need Word. You can see I already have GeoGebra installed on my PC. That means if you do not have it, find the software, open like that, double click, follow the commands, and you have it installed. And also you need Microsoft Paint. If you are not able to see it on your desktop, go to search, type Paint. You can see the software Paint is there. Right click and say pin to taskbar. Or when you say pin to taskbar, it will come to your taskbar, and you can see it's here. It's here on my taskbar. So once all these are ready, we can start with GeoGebra. We double click to open, and when it opens, you need now to prepare your XOY plane. And this is what you do to prepare your XOY plane. Go to settings and do your scaling from here, and you can actually change your scaling from here. For example, you can put a 10 there and click outside. You can see the y-axis is now what we could call 2 centimeters to 10 units, and the x-axis is still at default 2 centimeters to 1 unit. So this is where you can actually do your scaling. This is where you can also prepare the XOY plane. You can see the show axis, meaning that we are able to see the x-axis and the y-axis, and also you can make it bold. Yes, you can see it has been made bold. And also we can come to grid here and also change the grid color from the way it is gray, the default color gray, to black, because this might not be visible if we printed and photocopied this grid. This might not be visible, so we need it in black. So we can change to black here, pick black there and say OK. You can see our grid has gone to all black, and we now need to go to another setting here, so we could change the font size. You can see the default font size is 16. You can actually make that one bigger, say to 24. So you can see the numbers have gone to 24. They were initially 16. This is 16, and we have adjusted them to 24 so that they are visible enough. So once we do that, we can close our settings and come to our grid, and you can see this grid is 1-to-1. So for example, if like the way our question is, our question, we are looking at this question from one of the ECZ questions on statistics, and you can see the scale is 2 centimeters to represent 10 units on each axis. 2 centimeters to 10 units on each axis. So we need to come to our GeoGebra and ensure that we have 10, 20, 30, and on the X 10, 20, 30, which is 2 to 10. So now the way you do it, the way you adjust your page on GeoGebra, you can simply move the wheel backwards. When you are using your mouse, you can roll the wheel backwards. You can see it's now 2 to 2, 5 to 5. Continue moving it backwards. You move it towards yourself, and you can see finally it's 10 on the y-axis and 10 on the x-axis. Now we all know that when we are looking at linear programming and statistics, we do not require the negative values of the x or y plane. So we can simply move the x or y plane so that we are able to see a majority of the positive values. So once we do that, we can do our plotting. Yes, we can do the plotting in advance. We can do the plotting in advance. Okay, so we can plot, and we plot the coordinates. So for this question, the coordinates that we are going to use to draw our cumulative frequency table, we have the coordinates 5, 0, 10, 5, 20, 15, and 30, this blank is supposed to be filled in by 40, then 40, 70, and 50, 90. Yes, so those are the coordinates that we are going to use to draw our cumulative frequency curve. So we need to pick our point there and start plotting. So we have 5, 0, 5, 0. So 5 is here between 0 and 5 is here between 0 and 10. So this is 5, 0. We plot there, and 10, 5, 10, 5. This is 10, 5. We plot there. Also 20, 15, 20, 15. We plot there, and 30, 40, 30, 40 there. Also 40, 70 there, and 50, 90, 50, 90, and finally 60, 100. and we do not need these names of these points, so we can remove them by pointing at each one of the points and right clicking. Then we say show label. So we do show label everywhere, show label. So we do show label everywhere. Okay, so we have removed the names of the coordinates. Now we can actually also change the size and color of the points by right clicking and coming to settings. And when we right click and come to settings, this will open and you can see there is color. So the default one is blue, we can change to black. And also there is a style. This is where we can also reduce the point size. If we want it smaller or bigger, we can adjust here. You can see it is a little bit smaller, 3. So we can actually do that one for each and every coordinate. We right click, settings, and come to color, black, style. We change the font, the size of the point. So we do that one to all the points. Okay, so once all the points have been changed into black and the point size reduced from 5 to 3, we can see we would have utilized our GeoGebra to the fullest towards drawing our cumulative frequency curve. At this point, we need to save what we have done on GeoGebra. As I earlier told you, we need GeoGebra, Paint, and Word to do the statistical diagram cumulative frequency curve. So once we do it here on GeoGebra, do part of it on GeoGebra, we need to come to settings here and say download as. Then come download as PNG, and we give it a special name. For example, I'll call it L Pro, and I'll export. And once this page opens, I'll choose where I'll save my L Pro. I'll save it on desktop, and it will just be on the desktop, so I'll say save. Okay, so once that is done, I'll need now to open a blank Word page. I'll need to open a blank Word page. So I'll say, okay, I'm opening a blank Word page. Okay, so that's my blank Word page. Once that one is opened, I'll need now to drag a part of my cumulative frequency curve that I did on GeoGebra. I'll need to drag it to this my web page. Okay, so I need to drag it. You can see it's here on the desktop. That part of the cumulative frequency curve that I did on GeoGebra that I called L Pro, you can see L Pro is here. So L Pro will be dragged to this Word page. Okay, successfully dragged there, and you can see we have whatever we had prepared on GeoGebra. So at this point in time, we need to connect the points, and we come to insert in the shapes, and we need to pick on this one representing a cave. You can see this one, cave. So we need that one for us to draw a cave. So we can now connect the points. So we click here, click wherever this all the points that we need to connect, we need to click on wherever this cave is supposed to pass, like that. Okay, so we have done our cave there. We have connected all the points. So now we can actually change the color and the thickness of this our cave by coming to drawing tools, and you can see there are colors here. We come here, this is black, this one is thicker than the other one, thickest this one. So you can see our cave has been drawn like that. Then we click outside the box like that. Then at this point in time, our work is done in Microsoft Word. Now we need to highlight all this and get it to paint. So we could say Control A, that's the shortcut for highlighting, Control A, and we see what we have done. After that, we need to copy, say Control C, and we can actually minimize this one and go to our paint. Paint, we need to double click to open, and this way now we need to paste whatever we had copied on Word. So Control V, so we paste, Control V, and you can see we have this our a cave. So we did the first part from GeoGebra, second part from Word, and finally now we are here on Paint. Now the essence of copying this one to Paint is for us to be able to do the scribbling. We can write under here, for example, this question on statistics has a example. There is part B that involves the diagram. Part B, Roman numeral 1. This the one that involves the missing values. So the missing values were 40. So if you want to put it here, 40, 70, and 90. Okay, so that's part B1. And there's also part B2, part B, Roman numeral 2. This one is the actual graph, so you can write graph. And there's also part B, Roman numeral 3, which is the part for the semi-interquartile range. Okay, so we can actually do so many things that we would want here. And let's look once more at the question. Okay, so looking at our question, we are told to draw. This we are told to complete, so we completed with 40, 70, and 90. Now, we are told that showing your method clearly, use your graph to estimate the semi-interquartile range. So, we have to estimate the semi-interquartile range. So, semi-interquartile range, we need to know our semi-interquartile range. We know it's half of the interquartile range. So for us to get the interquartile range, we need to get quartile 1. So quartile 1 of 100, since we are looking at 100 things, so quartile 1 of 100, this is 25% of the way up. Our way up is 100, so that's 25. So we need to produce a line from 25. 25 is actually in the middle of 20 and 30. So here we produce a line, and as soon as this line meets our curve, we can now drop it down. So we drop it, and you can see once it is dropped there, we can now read the value on which this one has been dropped on. So this is our, we can write this is 25, put it there, and 25 is helping us get quartile 1. Quartile 1. Yes, quartile 1. Yes. So this one is helping us get quartile 1. And 25 quartile 1. I didn't close the bracket, so now closed, and I can actually move it where it will be visible enough. Yes, like here, and you can see it's properly done. And my quartile 1 is also 25 here, so you can see, you can put a 25 there. Then also I'll need quartile 3. Quartile 3 is 75% of the way up, or 3/4 of the way up. Now my way up is 100, so it's getting to 75. So again, I can actually draw another line here from 75 up to the graph here. Then also I would drop this line to somewhere there. Yes. So if I want, I can make this line bold enough like this, that it's okay that way. And you can see it has dropped on this is 40. So you can see, according to this scaling, this is 40, this is 42, 44, 46, 48, 50. So this is 42, so I can type my 42 here. So 42. And also here 75, and this is quartile 3, the upper quartile. Okay, so that's quartile 3. Yes. So quartile 3 is 42, and quartile 1 is 25. So finally, my semi-interquartile range will be presented as follows. It's 1 out of 2 of quartile 3, which is 42, minus quartile 1, which is 25. So when we do this calculation, quartile 3 minus quartile 1 is actually 25 minus 42, or 42 minus 25. Okay, so calculating that one, it's getting to 42 minus 25 is getting to 17. Now 17 by 1 out of 2 is giving us 8.5. So actually 8.5 is our semi-interquartile range. So 8.5 is our semi-interquartile range. So once all this is done, all the necessary information is done, we need now to save this. We say save as on the same desktop. So I'll save it as L Pro, or let me save it Start Pro, and it will be saved on the desktop. Save like that. Okay, so all this work has been saved on the desktop. Now, coming to the like inserting whatever we have done on a web page, we can come to our question here, and you can see, we can say solutions, and we can actually bring our solution in the form of diagram. That diagram we have done down here, coming to insert, that's a picture, and it's on the desktop, and it was named Start Pro, and we can say insert. Okay, so our diagram has been inserted. Now we do not need this space here. All we need is just this grid. We can come to picture tools and crop, then crop all this unwanted space, and just remain with what you just want. Like you can even just leave that one, and you do it like that, and you say save. Then you can actually make this one bigger. You press on it and drag it to the right and drag it down. Yeah, so you could make it look bigger. Yes, so making it look bigger, you can actually drag it right and down like this, and this looks better when you do it in on the computer, and you print it, photocopy, all the details will be legible. Thank you for your patience. GeoGebra, Paint, and Word have been used to create this cumulative frequency curve. GeoGebra is also capable of helping you draw, construct, also helping you to draw, could also help you to draw all diagrams, those for trigonometry, vectors, all those linear programming, diagrams. GeoGebra is able to help you do that. Thank you very much for watching.